Alrighty, hi everyone. My name is John, and we are doing the Finding the Fountain of Youth. So every 67 seconds, someone in America is developing Alzheimer's. We all know someone that has developed Alzheimer's. Alzheimer's disease is a degenerative neurological disorder that causes memory loss, confusion, and behavior changes. The causes are from amyloid beta plaque buildup and tau protein misfunction. There are certain genes that can cause a higher risk for the development of this condition. With this image, we see that there is a normal brain, a mild cognitive impairment, and also Alzheimer's disease. You can see that there's a large amount of plaque buildup. The problem is that there is no cure for Alzheimer's disease, and treatments primarily focus on symptom management. The amyloid plaques are one of the earliest markers of the disease, but no method exists yet to effectively prevent their accumulation. Your genetics predispose you. Mutations on genes PSEN1 and PSEN2 and amyloid precursor protein APP can cause early onset Alzheimer's. So the challenges that are faced are genetic complexity. Alzheimer's is a multifactorial disease influenced by a range of genetic, environmental, and lifestyle factors, meaning that removal of this gene may not be the end-all be-all. The ethical considerations that need to be considered is that gene editing in humans raises ethical concerns, especially regarding long-term and potential misuse, and would require legalities to remain beneficial. And the technical limitation, although CRISPR and other gene editing technologies are promising, they are still in early stages and may not be ready for clinical applications. So the solution is CRISPR-Cas9. CRISPR could be used to modify the genes responsible for amyloid beta production, such as APP, PSEN1, and PSEN2, and targeting specific mutations in these genes could prevent amyloid plaque formation.
All right, so just to expand on what my partner was talking about, we were trying to take a biological approach. So we're looking at using CRISPR as a whole, not just for just mainly for early onset. So we're looking at anything hereditary or just genetic predisposition. So if any of you are not aware, we're looking at using CRISPR which is when we have a single-guided RNA. The single-guided RNA is combined with the Cas9, and then with the Cas9, we can look at the sequence. And while we're looking at the sequence, we can look at certain areas to target for the gene. So if we're using CRISPR as a whole, we can kind of use it as more so a catalyst for when we're looking at a wide range of things. This can relate to either stress factors, environmental factors, maybe things that could contribute to Alzheimer's, such as exercising, maybe, and there's an X amount of time that you exercise for things that you contribute. We decided to take this biological approach, and then even though it's not necessarily a relatively new thing, there's not such a heavy amount of things surrounding CRISPR, we're still hoping to explore it more. Yeah. And yeah, just to conclude, this is my teammates. These are my teammates. We have John, Jada, and also, I don't know why I'm blanking, I forgot your name. We have Lewis, I'm so sorry, and I'm Scott. And yeah, thank you, that's our presentation. Yeah, have a blessed day.
May you elaborate, please, in the innovation here? I heard like a nice presentation, but I still want to clarify what is the innovation.
Sure, so essentially with Alzheimer's, right now they're looking at treatments, but what we want to do is prevent it. So prevention is better than treatment. So using the CRISPR, we'd be able to identify genes that predispose you to Alzheimer's and essentially gene editing, cut them out. If you don't have the gene, you don't have Alzheimer's. That's the idea.
Okay, that's good. Thank you. Thank you.